is Chatelier's principle. Now, I absolutely love that this principle comes, I teach it to you at the very end of the year, because, man, I sure get stressed out at the end of the year. I'm assuming you do too. And you know what this principle is all about? It's all about how the chemicals respond, how systems of equilibrium respond to stress. So what we do is we take a system in equilibrium, apply a stress to it, and what's really cool is that the equilibrium system shifts to alleviate the stress. It does the exact opposite of the stress to alleviate the stress. Now you might be thinking, how in the world do we stress out a reaction? Here they are. There are three ways. We can either change the concentration of a reactant or a product, we can change the temperature, and we can change the pressure. Those are the three ways that we can stress out a system at equilibrium. Now this video that you're watching now is going to be all about changing concentrations. So this would be adding or removing a certain product or reactant. So let's go ahead and dive in and see if we can get this figured out. Remember, key point, it's going to do the exact opposite of what we are doing. Okay, whatever the stress is, the reaction is going to do the opposite of that stress to fix the problem. Something else before we jump right in, I want you to think about the KEQ again. Remember that KEQ is going to stay constant for concentration and pressure changes. So if we increase products, it's going to need to increase reactants in order to keep K the same. If we increase reactants, it's going to need to increase products to keep KEQ the same. So that might help you, and remember this is my very generic equilibrium expression. It's just the ratio, so this is very generic. Remember, in reality, we've got to add those exponents in there. But that might help you keep this in mind. Now, I've got a ruler here because I'm going to use kind of like a scale or a balance system, or you could think of it as a teeter-totter or a seesaw. The heavier something is, the further down it goes. So as we add more, if we add more product, it's going to shift this way. I mean, it's going to move this way, and if that means this side's lighter. So keep that in mind. I'm going to be using a ruler. Please, as you're listening, once this clicks, it's great. You'll be awesome. But I want you to actually be doing the seesaw with your pencil, or if you have a ruler, you can do it along with me. But I want you to see what I'm doing so you can figure out how to do this on your own. So here's the first reaction. N2 plus 3H2 yields 2NH3. This is a reversible reaction. What happens to the reaction if you increase the concentration of nitrogen? So here's the stress. I'll actually put the stress in red. Stress is going to be in red. Okay? So there's the stress. I'm increasing this. There's my stress. Now, I want you to hold up your pencils, hold up your rulers. If I increase N2, that means that this side's going to get heavier. Now, do you see how now it's out of equilibrium? We want equilibrium to be like this. Now remember, equilibrium does not mean equal concentration. So that's one thing, it means equal rates. But right now it's out of whack. Oh no, what's going to need to happen to get this back to here? First of all, we always talk about what side the shift is. That means that this reaction is going to shift in a way to help alleviate the stress. It's always going to shift on the side that's higher. So in this case, we added this. That causes this to go down. The shift is going to be to the right. Shift is going to be to the right to push this back down. So the first answer is shifts reaction to the right. Okay? Whatever side's higher, so we added this, causes this to go down, whatever side's higher is going to be the side that has the shift. Now, in order to get this to fall back down, what would we need to do to our product? In order to get this to fall back down, we would need to add some of it. So this is going to need to increase. We add it to get that to fall back down. And what are we going to need to do to the other reactant? to get this side to go up, we're going to need to decrease it. So shifts the reaction to the right, that's your first answer. NH3 will increase, and it's actually the concentration of NH3 will increase, the concentration of H2 will decrease. Now, it's all about figuring out what is your change. We stressed it out by adding in 2. So we added in 2. Now it's out of whack. The shift is the side that we have to push down to get it back to normal. So we're going to push down this way. Shift is to the right. Then the side that you push down is the side that you're adding. The side that you have to lift up is the side you're decreasing. So if that helps, definitely think about it that way. Feel free to use your pencils in your test. So let's think about some other things. The shift is always going to be, shift will always be away from an increase. That's our stress. If the stress is an increase, it's going to shift away from it. The shift will always be toward a decrease, which we're going to see that in the next example. So if we decrease something, you're going to shift towards it. And the side that's shifting is the side that we are increasing as a result of the shift. So if you notice of the stress, as a result of the stress, we shifted this side. So that's the side that's going to increase as a result. So there you have it. Let's do another example, because really this just takes quite a bit of practice. So example number 2, we've got a new reaction here, and we're going to decrease SO2. So here's our stress. I'm putting it in red. We're going to decrease this. Now I'm going to grab my ruler, and I want you to grab your pencils. And if we decrease the reactant side, would you agree that it would lift up? Why? Because it doesn't weigh as much. If we decrease this side, it's going to lift up. Now do you remember, the shift is to the side that we have to push back down. So we have to push the right side back down to get it back to where it was. So the shift would be to the right. Okay, now look over here. Toward a decrease. We decrease this, we're going to shift toward it. That's to the right, the product side. The reaction's going to shift this way to produce more of this and use up more of this. So this will increase, this will decrease. So let's look at it with this way. If we decrease SO2, this causes it to lift up. We're going to have to push this back down. That means we're shifting in this direction, the right side. That means that this side needs to increase as a result. O2 is going to increase. SO3 on this side, the reactant side, is going to decrease. So your answer would be shift right. SO3 concentration would decrease, and O2 concentration would increase. So far I want you to look at the 2 examples I've done, and I want you to look at my colors. You can see that the red is the stress. So this is what the problem told us is happening. The stress to the reaction is that someone came in there and added into. Now, look at the opposite side of the reaction. Do you see how the exact same thing is happening to the opposite side? We increase this, as a result, it's going to increase this. Now let's look at the same side. As a result, it's going to decrease the items on the same side. We added more reactants. Oh no. As a result, to fix the problem, we're going to add more products. The reaction itself will add products and decrease reactants. We added more reactants? No, now we have too many reactants. Add more products, take away reactants. See what it does. Same thing to the opposite side, opposite thing to the same side. We look at this one. Here's our stress. We decreased the products, so as a result, we're going to decrease the reactants, increase the products. Okay, let's do one more. If we increase O2, I'm going to erase my little arrows, so we're going to start a new one. Our stress is that we're increasing O2, so I'm going to put that in red. So let's look at my little seesaw. If we increase O2, that means this side's heavier. Oh, do you see what side we have to push down? We have to now push down the left side. So the shift is going to be to the left. That means that everything on the left side will increase. So SO3 will increase. That means everything on the right side will decrease. So that means the concentration of SO2 will decrease. Let's look at the seesaw to see if that makes sense. When we add O2, it causes the reaction that causes the seesaw to move down this way. Now we have too many products. So we need to reduce the products and we need to increase the reactants to get it back to where it was. The side that you have to push down is the side that it's going to shift. So it's going to shift to the left. So this does take some practice, but I know you guys can do it. Just go through the homework. Go through the extra practice problem in your note packets, ask questions when you need to, but you've got this. Thanks for listening.